Why is Chickenponics? Aquaponics have been introduced into Vietnam for the last 10 years or so. Since 2016, CAR has started to develop aquaponics system, targeted for urban households in cities Vietnam, with the system design that meet households' demand on various types of vegetables, herbs, fruits and even bonsai. However, aquaponics system is in serious risks in cases of electric cut or pump problems. For example, fishes start to die after about 3 hours of electric cut. This leads to a thought on new systems that are not badly hit by electric cut, as well as diversified choices for households, in parallel with aquaponics, that is, Chickenponics. The small demo of Chickenponics, constructed in March 2017, showed a positive result on development of different vegetables. However, we remained with a big concern on harmful bacteria and quality of vegetables for consumption. In June 2017, CARES received a grant from Alicia project under AFD grant for constructing a Chickenponics demo and testing harmful bacteria in wastewater and vegetable samples, and vegetable performance of the system. For this, 3 subcomponents were proposed. The first component is soilless hydroponics, the second is soil-based irrigated by wastewater taken from chicken system, and the third is conventional soil-based. Each subcomponent was of 4 square meter for growing vegetables. The Chickenponics bio-wasting system were constructed in 4 tanks. The first tank receives manure directly from chicken, second tank receives surface water from the first, and similar for tank 3 and 4. Pump is installed in tank 4. Initially, 3 auto valves were set between the 4 tanks, which were alternatively open for every 2 hours. So it will take 6 hours for the wastewater getting from tank 1 to tank 4. However, valve 1 and 2 did not sufficiently work because of their small size. We had to remove these 2 valves, kept only the valve connecting tank 3 and tank 4. Chicken manure is automatically cleaned to tank 1 for every 2 hours in daily time, and 3 hours in night time. And valve connecting tank 3 and tank 4 is opened for every 4 hours in daily time, and 6 hours in night time. 40 quails were adopted. 3 major vegetables were grown in the 3 subcomponents: kangkong, corcharis, and sourpuss. In soilless component, some other vegetables were grown as well, Colocasia gigantea, and some herbs. To facilitate vegetables growth, NPK was added in all 3 subcomponents, 7 times in soilless subcomponent, and 5 times in soil-based subcomponents. In addition, biocompost was added to soil-based subcomponents, for 4 times. Basically, fertilization was done in a frequency of 2 weeks. Despite hot temperature in July and August as well as high rainfall, vegetables were well developed in the first, soilless subcomponents. By contrast, vegetables were less developed in the 2 soil-based subcomponents. Especially, sourpuss were badly hit by such unfavorable climate conditions. For bacterial test of water samples, E. coli was found in water from drilled well but not in the Chickenponics system. Coliform was found more in tank 1, and reduced in tank 4. During the trial, EM was added to tank 1, 2, 3 on the day 50 and 70 at 16 gram per tank, equal to 100 gram per cubic meter of water, as technically suggested. But no significant difference in bacterial number was found, as compared with without EM. Water clearance can be seen largely different between tank 2, 3 and 4. For bacterial test of water samples, no salmonella, and E. coli was found in vegetable samples. Some coliform was found, but technically, vegetables are safe for consumption, according to Vietnamese technical standards. For bacterial test of soil samples, there was no difference in azotobacter, cellulose degradation, phosphate solubilization between the two soil-based subcomponents. However, more protein degradation bacteria and less aerobic microorganism were found in the second subcomponent that was irrigated by chicken wastes. As discussed earlier, hot and wet conditions in July and August did not support for vegetable growth in the two soil-based subcomponents. This resulted in harvest difference in the three subcomponents. Except Corchoris that growed in all three subcomponents with little difference in total harvest, Kangkong and Soropus performed much better in soilless subcomponent. As compared to the rest two soil-based subcomponents, there was no harvest of Soropus in soil-based subcomponents. Even though chemical tests are still needed to make adequate conclusions about quality of Chickenponics vegetables, from agronomic and bacterial views, we can basically conclude that Chickenponics is possible for small, integrated farming scale. This could be a good choice for households farming, given the increasing impacts of climate changes that do not favor for soil-based vegetables, especially in the hot and rainy summer season in the North Vietnam. In the Chickenponics system, oxygen enriched by air pump and the recirculating system helps largely reducing harmful bacteria in the bio-waste system. In the future, semi-Chickenponics system can be considered for medium-scale integrated farming. We would like to acknowledge financial grant of ALAC project for the research. Our special thanks to Mr. Pierre Farrand and Gret staff for their supports. For more information, please visit www.cares.vnuit.edu. Thank you for watching the video.